The focus of this lesson is on graphing by using a combination of transformations, so there's more than one. And the way we would go about doing it is we would first make sure our function is in the form that allows us to see all the transformations. So we could see here for the x's that we have a leading coefficient other than 1, so we should factor out that -4. And then when we do that, it's like dividing it out from every term in the parentheses here, and that leaves us x minus 2. And you can check that by distributing it back in and seeing that the parentheses set equals -4x plus 8. So then there, I notice I have all of the transformations kind of highlighted in a different color. So notice in black you have x squared. That's your parent function. So I'm going to go ahead and just write down f of x equals x squared, just to keep in mind that that's who we're transforming at the end of the day. So I'm going to go ahead and create a table. So if you're trying to graph by transformations, you should always start with the parent function and you should graph it. So 3 key points for f of x equals x squared would be if we pick like maybe x is -1, x is 0, and x is 1. And then what we're supposed to do with our x is we're supposed to square it, because that's what our function says to do. Square it, square it. But what values did I pick? -1 for x, 0, and 1. So if I square each of these, I'll get +1, I'll get 0, and I'll get 1. This gives us the ordered pairs -1, 1, 0, 0, and 1, 1. Then from there, I need to go ahead and perform my transformation. So I'm going to go ahead and graph each of these, and that'll give us our parabola. And then I'm going to go ahead and apply each transformation. Notice, according to my combination of transformations, the way I'm showing it, you would do the shifts last. So if you have any vertical or horizontal shifts, you would do those last. So the first transformation we have in green here, and this is where we have a negative in front of the entire function, in front of the whole f of x. When that happens, that means that you need to do a reflection. And since the negative is on the whole function, the y's, you reflect across the x axis. So let's go ahead and do that. So again, what it'll do is we'll actually negate our y's. So at the end of the day, our point becomes -1, -1, 0, 0, and 1, -1. And you can see it again if you reflect this function across the x-axis. Notice the point at the origin isn't going to change, but you will flip over this x-axis and you'd end up at -1, -1, and 1, -1. So I'm going to go ahead and just draw that in. So that's the reflection across the x-axis. Then next, notice in purple here, I have a multiplier of 3 on the whole squared x squared term here. So again, that's on the y's, that's on the entire function. So that should signify that this is a vertical effect. And I'll just put VERT for vertical. And then it's a stretch because the number you see is 3, which is bigger than 1. And then it's by a factor of 3, and I'll just put by 3 just because of for room sake. So then what that means is your y's multiply by 3. In other words, they're going to get stretched out by a multiple of 3. So if we did that, notice this point is at 1, -1. It would become 1, -3 instead. Point at the origin isn't going to change because if you took 0 and multiply it by 3, it doesn't change. At 1, -1 will go down to 1, -3. So that'll get you your vertical stretch by a factor of 3. And again, just if you're trying to follow along point by point, you can see that the y coordinates are what affected. They're multiplied by 3. And again, if you multiply 0 by 3, it's not going to change, so it looks like it's unaffected, even though you did do the multiple. And then next, notice we have this negative here as a multiplier, and it's happening inside of the square, so it's happening on the x. So that should signify that you reflect across the y-axis. And then if you do that, that means again that you're negating your x's. So from a point standpoint, that's what should happen. But again, if you reflect across the y-axis, notice your purple graph here, if you flip it across the y-axis, is not really going to change. So because, and the reason being, is that would negate all your x's. So this would become 1, -3. But notice that's this prior purple point that I'm pointing at with my mouse here. And then this would stay 0, 0. And then if you multiply by -1 on your x here, it'll become -1, -3, which is this point, the first point in purple. So notice you get the same points back, and so it doesn't look like the graph changes. So I'll just kind of go back over it so you can see that it just kind of stays the same. The red graph is the same as the purple graph. And then notice the next transformation is we have a multiplier on our x piece. So it's inside of the squaring function, so we can tell it's happening to the x's, so that should trigger that you have a horizontal effect. So I'll put HOR for horizontal. But then think about the reciprocal of 4, so that's 1/4, so that should signify compress. So you're going to horizontal compress by a factor of its reciprocal there, which is 1/4. And so what that means is all your x's multiply by 1/4. So whatever was there, you multiply by 1/4. So 0 will not change. And again, you can do it point by point, or you could just do it directly on the graph. So if we show it on the graph, notice again, this point's not going to change if you take x and multiply it by 1/4. But notice your x value here is -1. So when you pull it in by multiplying by 1/4, it's going to be at -1/4. And so you can see it compressing down. This x value here was at 1. If you multiply it by 1/4, that pulls you closer to that y-axis. So you're compressing down, you're smashing down onto that y-axis. And then last we have, it appears to be a shift. And again, by the way that I'm showing it, you should be doing your shifts last. Notice that this says -2 on the x, so that should signify that it's horizontal. And then since it's minus, we know we need to go right. So it's right 2 units. So let's go ahead and take our blue graph and shift it to the right 2 units. So the point 0, 0, if you shift it to the right 2 units, would put you at 2, 0. So I'll just go ahead and label that here. We have this point at 1/4, -3. If we go 2 units to the right, it's going to place us at 2 1/4, -3. And then last we have this point at -1/4, -3. If we go 2 units to the right, it's going to place us at 1 3/4, -3.
Now let's go ahead and do the last step. So we have this -8 here, which is a shift, and since it's minus, it's downward, so we're going to go down 8. So that means all of our points have to move down 8 units. So basically, at the end of the day, that just means we need to subtract off 8 from the y-coordinate. So you can keep all of your current x-coordinates, so I'm just going to go ahead and write those in, so you can see nothing changes with those. So we still have 2 1/4, 2, and 1 3/4. But all the y-coordinates, like we said, need to go down 8. So if you shift down 8 units, that's going to go to -11, -8, or -8, and then also a -11. So those are your 3 points, and then you go ahead and go to plot those. So I went ahead and took this red graph that we had and I moved each of those 3 key points down 8 units, and we end up right here, and that would be our final graph with all those different transformations.